Hi, and welcome to our capstone project showcase, Financial Assistant for Visually Impaired. As implied by the title of this product, it is solving a problem that is.
People with impaired vision face difficulty in accessing financial service. In fact, study found that 76.5% of individuals who were self-report as visually impaired are asking someone else for help on a banking or finance system. The previous attempt to address this problem has been done before. With approach used are having user experience focused on interacting with UI elements. Unfortunately, these products are not updated anymore, and in fact, having low penetration to target users. So we try to rethink the solution by using voice and speech recognition to help visually impaired people accessing finance service. This approach has several advantages that is doesn't rely on UI element label used by device accessibility settings. Easier customer identification for visually impaired people by recognizing their voice characteristics. Raising involvement of third party to assess the visually impaired people in doing financial service. Now you may ask the reason why the solution is built in the first place. Simply put, because we believe in financial inclusive features that support visually impaired people. The solution benefited a great many of people, in fact according to United Nations Development Programme. Indonesia is the country with the second highest rate of blindness in the world. So today we will show you a product that can change their life.
Meet FAVI, a financial assistant for the visually impaired. Our product is meant to be an alternative to standard mobile banking services. Mobile, meaning that we are going to target the Android platform, and our main customers are the visually impaired. Our product's main objective is to provide a financial services that is more accessible for the visually impaired. We from the mobile development team have four main points that we want to express on our process on developing the Kotlin-based Android application for the user. The first one is about our authentication system. We decided to use the Firebase authentication library on our app based on our Mentor's advice, and it made the development process easier. The second one is about our database system. We initially decided to use the RESTful API services that is going to be made by the cloud team, but we abandoned this idea and we decided to use the Firebase Firestore system, and it made the development process easier. The third one is about our model implementation. We initially implemented the TensorFlow-like model directly in our app, and we were successful. But the production result is not as good as we expected it to be, and we abandoned this idea and we decided to use the server instead to process the data. The last one is about our speech command system. As we explained in the third point, our app can recognize the use of speech commands such as tambah or transfer. This feature can be used in the main menu and the add fun activity. But as of now, we are really restricted in these features because of our current model's restriction, such as the bidder can only produce so much command.
For the model, we use mostly convolutional neural networks CNN-based model with two-dimensional convolutional for temporal data such as audio waveforms, since we have transformed the audio files into spectrogram images. This model built with Keras Deep Learning Framework and TensorFlow machine learning library. The model also has the following additional preprocessing layers. First, batch normalization, that is applies a transformation that maintains the mean output close to 0 and the output standard deviation close to 1. And the second one is dropout layer, that is randomly sets input units to 0 and the frequency of rate at each step during training time, which helps prevent overfitting. For the dataset use, we use FAVI speech command dataset. This dataset consists of over 5,800 waveform audio files of people saying 29 different words in bahasa spoken by dozens of different subjects. This data was collected by the late night studio team. For the classes, at this time, only 12 classes will be picked for the Android speech command application. For audio processing, data generation involves producing raw PCM waveform, data containing a desired number of samples, and at fixed sample rate, and the following configuration is used. samples by 16,000, sample rate by 16,000, and good duration is 1,000 in millisecond. For the model result, after training the model for 100 epochs, the following confusion metric was generated for assessing classification performance.
Okay, here I would like to explain about cloud computing within FAVI development. We are from Cloud Computing Path is developing several computing apps using cloud function. And actually, there are many ways to build several apps. For example, there are Google App Engine, Google Cloud Run, Google Kubernetes Engine, and Google Cloud Function. So, why do we choose GCF? We choose GCF because we would like to connect to third-party cloud service. In this case, we use Firestore. So when the Android gives the input voice from the user in our bucket, the cloud function can make a trigger to start the machine learning to make a prediction. And then after the prediction result comes, it sends the prediction to the Firestore so that the Android can pull the prediction directly. Okay, next. This slide is shown how the detail of FAVI deployment in Google Cloud Platform. The first, we store our speech dataset into cloud storage, and then doing training in AI platform. From training, we save the model into cloud storage bucket, which is in .fb format by default. After that, when the Android got input from the user, the voice is stored directly into the cloud storage. So that can trigger the cloud function to do the deployment. And then the prediction result is directly stored into Firestore so that the Android side can pull the prediction result and can easily manage as it's a real-time update. Okay, the next is development result. The result of 3 learning paths are Kotlin-based Android application with 6 main features, as you can see in the slide.
As you can see, our team put a great effort in building FAVI. Now, let's talk about business. This product targeting visually impaired people in a productive age that have access to a smartphone. We're calculating 1.5 million people in serviceable attainable market of this product. Now, let's talk about feature. So in the first phase, use an app integration with the banking system. We'll explain it in the detail later on. And on the phase 2, there's a development of a killer feature. Voice-enabled financial advisor. And this is a feature of FAVI. Imagine if you can just ask something like, hey, do I have money to go tonight? Or even something like, can I afford to have one more child? Yeah, we hope the answer will break the banyak anak banyak rezeki stigma. So there's no one that blame a government. Okay, keep in mind this feature can also be used to a general bank customer. That's why you see a target user expansion in a phase 4. What we described before is a part of our project milestone for 2021 that started with feature integration in early July and ending with app integration with banking system in December.
Now I will try to present it about the sustainability. This product has two main sources of income, that is 5% of transaction fee and the subscription fee, with the potential monthly revenue about 30 million Indonesian rupiah. We also have 5 efficiency priority to sustain our operation, as you can see in our slide. Next. Based on the 5K or 10K US dollar budgeting, we are expecting to 10,000 US dollar budgeting can increase our runway by 2 times, and also having a salary to hire one more person in 4 months. So we can achieve positioning in financial services that cater to visually impaired. So that's all from our team. Thank you.